All right, so for number one, we need to factor first. I can factor out 3a squared from the first numerator, leaving me with a squared plus 4. And a squared plus 4 does not factor. The denominator, looks like we get a minus 2, or a minus 2 squared. That second numerator, we can factor out a 4. I'm going to do that up here first because I know I can factor again. I get a squared minus 4, and then that's a difference 2 squares, so we can factor again to a plus 2, a minus 2. In that denominator, I can factor out 6a cubed, leaving me with a squared plus 4. And so now, looks like a squared plus 4 will cancel. I can cancel out an a minus 2. 3 can cancel out with turning the 6 into a 2. I have an a squared I can take out. That leaves me with an a down here. Now that 2 can simplify with that 4. At this point, it's a little messy. It looks like the numerator is 2 times a plus 2. The denominator, I have an a and an a minus 2. Make that look a little bit more like an a. Okay. Number 2, same thing. X, oops. So it can be an x plus 3 and x minus 5. The denominator, x minus 2 and x minus 3. Second fraction, x plus 6, x minus 2. And then we have x plus 5 and x minus 1. Cancel out, let's see, x minus 2's. And I think that's all that I have in common at that point. So x plus 3, x minus 5, and x plus 6 makes up the numerator. X minus 3, x plus 5, and x minus 1 makes up the denominator. Okay, number 3, factor out a 3 from the first numerator. Let's see. To factor this, could get, yeah, okay, looks like it could go 2z and 2z. I'll have a negative 3 and a positive 1. If I think about FOIL, this makes negative 6z right there. That makes 2z right there, and so together that's negative 4z. So that is factored correctly. Then instead of division, I'm going to multiply by the reciprocal, so I flip those around. So in the new numerator, I have a 2z and a z, yeah, plus 1 plus 1. And then in the denominator, I'll have z plus 2 and z plus 1. Cancel out a z plus 1, z plus 2, 2z plus 1, leaving me with 3 over 2z minus 3. Number 4, we have complex fraction. I'm going to focus on this numerator first. Factor that. Factor out of 4a. Leave me with a minus 3 over, and then it's a plus 2a minus 3. And then instead of dividing by this fraction, I'm going to multiply by the reciprocal. So I'm going to take and flip that fraction around. So I get a plus 2a plus 1 in the numerator. Factor out of 6a squared, leaving me with a plus 1 For the denominator, I can cancel out a plus 1s, cancel out a plus 2s, cancel out a minus 3s. The 4 and the 6, I can divide both by 2, giving me 2 over 3. I can cancel out an a, so I'm left with an a there. So in total, I get 2 over 3a. Number 5, I need the least common denominator. I'll have to include an a plus 2 factor and an a plus 4 factor. So I have to multiply the first numerator by a plus 4. So distribute the 2, I get 2a plus 8. Second fraction, I already had the a plus 4, so I brought in the a plus 2. So multiply 3 times a plus 2, give me 3a plus 6. Combine like terms, 5a plus 14. That numerator does not factor, so there's the answer. Number 6, I need to first check out these factorings. A plus 3, a minus 1 for the first denominator, a minus 2 and a minus 1 for the second one. So they have an overlap of a minus 1. So I'm going to have an a plus 3, going to have the a minus 1, and I also need to include a minus 2. Together, that will make up my least common denominator. That means the first fraction, it was missing the a minus 2 part. So that's what I multiplied to the denominator, so I have to multiply to the numerator as well. Distribute the 3, 3a minus 6. Second fraction had the a minus 2 and the a minus 1 part. It didn't have the a plus 3 part. So I have to multiply that into the numerator as well. So 2a plus 6. Remember, it's a subtraction problem. 3a minus 2a is a. Negative 6 minus 6 is negative 12. I'm going to fix that 12. Kind of runs into the line. There we go. Number 7. They're already factored, so include x plus 7 and x minus 8 in my denominator. First fraction, I had to multiply it in by x minus 8, so 3x minus 24. Second fraction, I needed to bring in the x plus 7, so 4x plus 28. Add them together, 7x plus 4. Number 8, that first denominator, I can factor a 2 out. Second denominator, I can factor a 2 out. So least common denominator includes a 2, an n plus 3, and an n plus 2. First fraction, I need to multiply n and n plus 2. The top and bottom, giving me 5n plus 10. Second fraction was missing the n plus 3. So multiply that, you get 3n plus 9. It is a subtraction problem. 5n minus 3n is 2n. 10 minus 9 is 1. Number 9, I'm going to recommend first combining the numerator into one fraction, making a common denominator. So the first fraction I multiply by x minus 2, so 2x minus 4. Second fraction multiply by x plus 1, so 3x plus 3. So you combine that together, it is addition, you get 5x minus 1. And then it was a division problem. So instead of dividing, I'm going to multiply by the reciprocal of this fraction. So times x plus 1 over 5x minus 1. 5x minus 1's cancel. X plus 1's cancel. I don't have anything in the numerator, so it's a 1. And then x minus 2 in the denominator. Number 10, I would multiply by the least common denominator, which is 3 and an n. And distribute that throughout, so 2 times 3 and 6n. When you multiply it to the 4 over n, the n's cancel, so you have 4 times 3 is 12. And when you multiply the 3 into the 1/3, the 3's cancel, so you get 1 times n, which is n. Subtract the n away. Divide by 5. So 12/5. Number 11, least common denominator, looks like 4 goes into 12, so 12 takes care of both the 12 and the 4. But I also have to multiply in y plus 3. So when I multiply it to the 4 and the 12 simplify, making a 3. 3 times 11 is 33, and then I also have the y plus 3. Then it's a minus. Next, the y plus 3's cancel, so you get 5 times 12, which is 60. Then I run to the equals. Next, the 12's cancel, leaving us with 23 times y plus 3. So you have some distributing and simplifying to do here. All right, so I'm going to subtract the 23. Well, here, this, first of all, I can make that a 39 rather. Subtract the 23y over, so 10y. Subtract 39 away, making 30, divided by 10, y is 3. Number 12, I would first factor this denominator. I'm going to multiply by the least common denominator. In the first fraction, that cancels out with the denominator, leaving us with 12p plus 19. Minus. Next one, the p plus 3's cancel, leaving us with 3 times p plus 4. I'll distribute that. 3p plus 12. That negative is going to distribute to both of those. P plus 4's cancel, so we get 5 times p plus 3, distribute. Oops. 5p plus 15. 12p minus 3p is 9p. 19 minus 12 is 7. Subtract 5p from both sides, giving us 4p. Subtract 7 from both sides, giving us 8. So p is equal to 2. Graph. Vertical, that's determined by your denominator, so x equals positive 3. Horizontal, f of x equals, look at your k value, that's negative 4. So in our domain, we cannot have an x value of 3, so I would say x doesn't equal 3. For our range, I would just say f of x does not equal negative 4. So an asymptote, vertical asymptote of 3. Horizontal asymptote at negative 4. Pick some numbers to the left of 3. That would be like 1 and 2. To the right of 3, 4 and 5. Plug them in. Plug in 1, your denominator becomes negative 2. So you get a positive 1/2 minus 4 is negative 3. Plug in 2, my denominator becomes negative 1. So I get 1 minus 4 is negative 3. Plug in 4, my denominator becomes 1. So negative 1 minus 4 is negative 5. When I plug in 5, I get a denominator of 2. So negative 1/2 minus 4 is negative 4 1/2. All right, connect the dots and follow the asymptotes. Okay, number 14, x equals -1 for vertical. Horizontal, f of x equals -2. So domain x does not equal -1. Range f of x does not equal -2. All other real numbers are okay. So table of values. So around -1, I could go with -3 and -2. Then on the right side, 0 and 1. -3 plus 1 is a -2 for a denominator, so -1 minus 2 is -3. Plug in -2. Looks like a -4. Plug in 0, get 0. Plug in 1, get -1. Connecting the dots with consideration to the asymptotes. Okay, now number 15, we get a more complex denominator. I'm going to factor that. X plus 2 and x minus 4. So we have two vertical asymptotes determined by our denominator. So x equals -2 and x equals +4. Horizontal asymptote would be 0 because the denominator has the larger degree. I'm going to plug this into calculator so I can find my table of values quickly. Okay, sorry, I had to change the mode of the calculator. Okay, so if I go to the left of -2, I can go with -4, -3, gives me 0.19 and then 0.43. So I can see, because of that asymptote, that it's going to hit those points, follow the asymptotes. To the right of -2, I could try like -1, get -0.6, could try 0, give me -0.38. I'll just go 1, 2, 3, I'll just get them all. -0.33, -0.38, and -0.6. It's kind of symmetric there. So we end up with something like so. And then to the right of 4, plug in 5 and 6, get 0.43 and 0.19. So it looks like so. Then over to this one, x is -2 is our vertical asymptote. The degrees are the same in the top and bottom, so look at the leading coefficients. 1 over 1 is 1. That's our horizontal asymptote. So our domain, I didn't do my domain in the last one. Domain didn't equal -2, and it didn't equal +4. For range, f of x didn't equal 0. This one, x doesn't equal -2, f of x doesn't equal Oops, I didn't say not equal to on the last one. Doesn't equal to 1. Make a table of values surrounding -2. So we could go with -4, -3, and then -1 and 0. So we would get -4 over negative. That's 2. Plug in -3. We get 3. Plug in 1. 1/3. Oh, that's a -1. -1 is -1. Plug in 0 and I get 0. So there's that branch. -1, -1, 0, 0, giving us this branch of hyperbola. Variation. Y varies inversely as x. You can either say y equals k divided by x and find out what k is and solve it, or you could say y sub 1 x sub 1 is equal to y sub 2 x sub 2. I prefer this option. So you plug in. Here's one set of data, 5 and 5. The other set of data, we don't know what y is when x is 45. So we're just going to divide by 45. So y is equal to 25 over 45. Both of those can be divided by 5, giving us 5 over 9. Number 8. Varies jointly as x and z. So you can make that equation and solve for k, or you could have y sub 1 over x sub 1 z sub 1 is equal to y sub 2 over x sub 2 z sub 2. That's the one I prefer to use. So I'll do that. Here's one set of data. So plug that in. 6 over 4 times 12 is equal to, and then your other set of data is right here. We don't know what y is. We know that x is 24, and z is 5. So if we clean this up a little bit, first of all, I could simplify that to 1/8 is equal to y over 120, cross multiply, 8y is equal to 120, 15. All right, varies directly. So sales, maybe I'll call that S. Varies directly with the amount of money spent on advertising. Maybe I'll call that A for advertising. So I could say S equals K times A, or I can go ahead and say S sub 1 over A sub 1 is equal to S sub 2 over A sub 2. So if last week's sales were 2,000 and 10,000, 2,000 is on advertising. So sales was 10,000. Advertising was 2,000. What should be the sales during the week that 1,200 was spent on advertising? So first of all, strike 3 zeros from each of those. So we're looking at 10 over 2 is 5 over 1. Cross multiply. S is equal to 6,000. We would expect $6,000 in sales. And then lastly, number 20. The distance a car travels, let's call that D, on a certain amount of fuel varies inversely with its speed. So speed is S. So you could say D equals K over S. Or we can say D1 S1 is equal to D2 S2. So distance, car travels 50 miles per hour. Sorry, that's our speed. Travels 336 miles. So it's 10 gallons of fuel. Notice that's a constant in both of these 10 gallons of fuel. So you just ignore that. That's not an important piece of this problem, as long as they're the same. So distance was 336. Our speed was 50. Over here, we're trying to figure out our distance. Our speed is 60 miles an hour. So we can divide by 60. 336 times 50 divided by 60 280 miles. So as your speed went up, your distance went down.